Hello everyone and welcome to this next session on Cat Diaries. So today we'll be solving from today onwards we'll be solving problems on similarity where the triangles will be similar. We'll apply the properties of similarity and we'll reach on to the answer here. Okay, so we started with triangle feasibility problems in lines angle triangle. That was our first type. Then we went on to equating area to find out area or length. Then we came on to the problems on external angle. Okay, the sum of the two interior angle is equals to the exterior angle. We solve problems there, and now we come on to solving the problems which are based on similarity. So let's see in which year were the problem asked on similarity in your cat paper and how do you deal with them. So before I start with our first problem that came in the year 2003, which was based on similarity, let me just give you a brief concept about what is similarity. Yeah, because most of you may not be aware of this. Maybe you're not done with the topic of geometry till now. So all that I tell you right now about similarity is all that you require to solve all the problems which are there in your cat paper. Okay, based on the concept of similarity. So just understand this simple concept and you will be able to solve and understand all the problems that I'm taking on similarity. So what do you understand when I say two triangles are similar? What do you understand? Or if I change my question and I say you that the two triangles are congruent, what is the meaning of that? All that you know for that are tests. There is an SSS test, some other test, XYZ test, and then you prove it, okay, without understanding what is actually the meaning of a congruent triangle. And it's very simple. Don't think of all these tests, okay, that will make your life complicated. Keep it simple. You will be able to understand the problem better. So if I say that the two triangles are congruent, what is the meaning of this? So say this is a triangle. Okay, a red triangle. And if I draw one more triangle, let's say a blue triangle, which I put it here. Now, when do I say that the red triangle is congruent to the blue triangle? When I can superimpose them. What is the meaning of superimpose? I can take this triangle and I can keep it on this. Is it being superimposed completely or exactly? Yes, it is. Okay, if I just cover this small part, you can say that yes, they are being superimposed completely. Can you just ignore? Now, let me just cover it completely. Something like this. So, can you superimpose them? Yes, which means that the two triangles are same. They are one and the same triangle. That's why you say they are congruent. So, in short, if I say I draw a triangle here like this, and now if I just say that I need to duplicate this triangle. Okay, what do you mean by duplicate? Just make one more triangle like this. So these two triangles I would say are congruent, okay, because they are clones of each other. They are exactly same, one and the same. That is the meaning of congruent. Okay, triangles are one and the same. But if I draw say one triangle which is, let's put it in this way, I draw one triangle here which is like this, a right angle triangle, and I draw one triangle here which is like this. Okay, let's say this is an isosceles triangle. Are these two triangles congruent? Just simple. Take it here, put it on this. Can you superimpose them? No, I cannot superimpose them. So they are not congruent. Congruent means the two triangles are same. We're talking about the same triangle. That's why you say they are congruent. And that's why you complicate this further by saying there is something called as SSS test. What is an SSS test? The all three sides are same. So if all three sides are same, the triangles are congruent. Why do you need to go for that? Just take one triangle, superimpose another. If they fit, if they match, they are congruent. If they don't fit, they are not congruent. That's how simple it is. Okay, so that is a concept of what you call for as congruent triangle, or if I were to say in one word, same triangle. So if this is congruency, what is similarity then? How do you say two triangles are similar then? So let me draw here one triangle, which is say this triangle, this black triangle. Now what I do here is I take a magnifying glass and I put it on this triangle. So what will happen? The image of this triangle will get magnified, yes, right? So what will happen if this was 2? Say the length of this side was 2. It got magnified 10 times. This will become what? This will become 20. Say this was 1. It got magnified 10 times. So this will become 10. Say this was 3. So it got magnified 10 times. This will become 30. That's how it is. So what is similar triangles? There is one triangle, okay, and you magnify that triangle and you say that this is other triangle which is magnified from this. So they are similar. And how do you know them best? Take the ratio of their side. 20 upon 2. What is the ratio? 10. Because it got magnified 10 times, right? That will always be the ratio. This is 1. This is 10. So 10 upon 1. The ratio is again 10. This is 30. This is 3. 30 upon 3. As you can again check it, the ratio will be 10. Because it got magnified 10 times. And that's what you understand when you say similar triangle. So if I say this is triangle ABC, if this got magnified as a triangle PQR, then you say that if these two triangles are similar, if it is being said to you that these two triangles are similar, what do you know then? If they are telling you they are similar, you know that the ratio of their side will be having one constant term. Ratio of their side means PR. PR is 20 upon AC. Then your PQ, which is 10 upon AB, that is 1. Then your RQ, that is 30 upon BC, that is 3. The ratio of all this will be constant, that is equal to 10 because it got magnified 10 times. So when two triangles are similar, the ratio of their side is same. That's what you understand. Something that you must have memorized, okay, without actually understanding how does this thing happen. Okay, because it is getting that much times magnified. So that's why the ratio has to be same, right? It will always be same. So for if I say, if for example, if I say this to you that let's change the ratio. If I'm saying you that it got magnified 5 times. So what will you say? If this is 1, this will become 5. If this is 2, this will become 10. If this is 3, this will become 15. Such that the ratio will always be same. 15 upon 3, 5. 10 upon 2, 5. 5 upon 1, 5. The ratio has to be same always, whatever it is. Earlier it was 10, now it is 5. That's what you understand when you say that the two triangles are similar. Okay, so know this property because it will be helpful for you to solve many problems. Whatever related property, one or two here and there, that comes with this, I'll tell you as we solve those problems, but this is the basic. You should know this before I solve the problems on similarity in CAT paper from 1990 to 2021. Okay, I hope all of you got this. Now there is one more thing that you're supposed to know, which again is being very much complicated by giving it very much tests, okay, like this test, that test. So if I ask you, how do you prove that the two triangles are similar? How will you prove? You cannot say that, okay, I magnified this, so I can see that there's a magnified image of this. No, you cannot be sure just by looking at this, right? Yeah, if I draw a triangle like this, and if I draw another triangle like this, can you say this triangle is magnified to get this? You can't be sure. How do you know that? Just by looking at it? No, you cannot say that in geometry just by looking at it, right? Okay, or else if I say there is one more triangle that I make it here, which is say like this. So can you prove that these two triangles are similar? You will say visually I can say they are not similar. Yes, very much. But can you say that these two triangles are similar? You can't be sure. It can be similar, it cannot be similar. So you need certain tests, okay, to prove that two triangles are similar. Because only when you prove that two triangles are similar, you can apply the property, which is ratio of their side will be a constant term. That is the extent to which they are magnified. So for that, you need to prove that the two triangles are similar. Now, how will you do that? So for that, you just need to know one test, that is A test. By this, will you be able to solve all the problems that I take from CAT paper 1990 to 2021? Yes. Just by knowing this one test, you will be able to solve all the problems. So what is AA test now? AA test means two angles are same. I am proving that. For example, I want to prove that is this triangle, which you can see it here, ABC. Okay, let's say this is ABC and this is MNP. They are asking me prove if ABC is similar to MNP, and this is the symbol that we use for similarity. If two triangles are similar, that's how you put them. So what will I say that? I'll just prove that two of the angles are same. How you will prove that? That I'll show it to you as we solve the problems. Okay, but you just have to prove that the two angles of these two triangles are same, which means these two triangles are similar. So if I am proving that this is 30° and this is also equal to 30°, which means you can say angle P is equals to angle C. Similarly, if I say that this angle is equals to 50° and this angle is also equal to 50°, which means what? I proved that angle P is equals to angle C and angle N is equals to angle B. Why only two angles? Third will automatically become equal. Sum of the measures of angles of a triangle is 180°. So you said that this is 30, this is 30, so P is equals to C. This is 50, this is 50, so N is equals to B. So 50 plus 30 is what? 80. So this angle will automatically become 100. Now you don't have to say AAA test. Third angle will automatically be equal. You don't have to prove that. That's logic. So stop wasting your time by AAA test. It's AA. Third will automatically be there. So angle M will automatically become equal to angle A. But they both will be equal to what? 100°. So if I prove that the three angles of a triangle are same, then I can say that the two triangles are similar. Okay, that's how you prove them to be as similar. That's when I can say this is being magnified to get this. Okay, because it's a smaller triangle, so you can say this is being magnified to get this. The magnification may be very small here, which is say 2 times, or say it's just 1 time. Then they will be congruent actually. Okay, if the magnification is 1 time, which means if this is 235, this will also be 235. The magnification is only done once. It will be one and the same thing. That's logical. If the magnification is done twice, then the ratio will be 2. Okay, so understand this very well. Are all congruent triangles similar? Think about this. Are all congruent triangles similar? Yes, of course they are. Because the ratio of their side is same. If I say one triangle is having the side 5, 5, 5, the other triangle is same, right? In congruent triangles, the other will also have the side as 5, 5, 5. So if you take the ratio will be 1, which means the magnification is done 1 times. It is just not magnified. It's one and the same. You're watching it through an ordinary glass, not a magnifying glass. It did not get magnified. You're watching the same triangle. Okay, when it becomes 2, which means now they are similar because the magnification is twice. This is magnification 10 times. This is 5 magnification 5 times. Okay, and if it is 2, magnification twice. Means double. If this is 2, this became 4. If this is 5, this became 10. Right? That's why you have to understand it in this part. So I hope all of you got the idea about what am I trying to say. So first of all, let me just revise this. First, we understood what is or what are congruent triangles. Then we understood what are similar triangles. Then we understood what happens if I say two triangles are similar, the ratio of their side will be same. Then we understood how do you prove that the two triangles are similar. How do you say that if I take this as a triangle, let's say this is a triangle that I take, and I draw one more triangle which is here like this. So how do you say that the two triangles are similar? By saying that the three angles, this is equal to this red is equal to this red, and this blue is equal to this blue. That's when you say that the two triangles are similar. And I showed you a simple test, which is A test. Just prove that the two angles are equal. How will you do that? By applying the concept of lines and angles, which is say alternate angles, corresponding angles, all simple concept, which I'll explain you as we solve those problems. So in case you are wondering, I had not done with geometry, I won't get all these things. You had already done all these things as you studied your maths from 6th to 10th. And I'll revise all these things once we solve those problems. Right? So don't worry about all these things. Even if you're not done with geometry, you will get all the problems. So that's what we know it till now. Now, before I take that problem, which I showed it to you at the start, let me just show you by visualization. Okay, if I'm saying that the three angles are equal, then you say that the two triangles are similar. You prove that the two triangles are similar. And if you prove that the two triangles are similar, you are saying the ratio of their side will be equal to same. Some one common number, that is a magnification. How does this thing happen? Okay, don't take everything that I say. You are thinking, okay, A test, I proved it. How when you say that the three angles are equal, two triangles will become similar, which means one triangle is magnified to the other. Right? Now let us visualize this and end this understanding on similarity so that we can start with our problem. So this is just a small illustration of what I just said, that when you say that the three angles are equal, the two triangles are similar, then all the properties of similarity, that the ratio of their side will be same, will be following. Right? But how do you say that when the three angles are equal, the two triangles will be similar? Which means you are saying if the three angles are equal, I am saying that this triangle is magnified to get that triangle when the three angles are equal. How do you visualize that thing? Okay, let's understand by what you can see on the screen. So there is one triangle here, ABC. Okay, what are their angles? So say one of them is, say, let's put it randomly. Okay, one of them is 48, one of them is 64, and the other is 67.9. Sum of the measures of a triangle is always 180. Okay, actually you can see from here. Okay, put the triangle anywhere. As you can see the value, if this becomes 76, 77, anyways, add three angles at any point of time. Take any triangle. Whatever is the measure of three angles that you get in any of these cases, just add them. It will always be 180. Okay? That is how you prove that the sum of the measures of angles are 180. And that's why I said just go for A test. If two angles are equal, the other will automatically become equal. So I'm saying that I take a triangle where, say, let's one of the angle is 44. Let's keep it like this. The other angle, let's say, or whatever that you can see on the screen. Can you say that this triangle is similar to DF? By visually looking at this, you can't say anything. Okay, that's why you say that. Just prove that the two angles are equal. So if I say this becomes 44, okay, this becomes 44 like this. So angle A is equals to angle D. And then when I say, and one of them becomes equal. So this is what? This is 70. Okay, so let's reduce this. Let's reduce this to 67. The upper angle is also getting changed, but just visualize that remains same. So this is 67.4 as we wanted something here. It is very sensitive here. So say this is 67.4 here. And this becomes equal to 44. So this will change, but I just hope you are able to visualize. This becomes 44. So the third angle will automatically become equal to this. So when this thing happened, this triangle is exactly magnified to get the other triangle. Okay, that's what you understand. Because then it has to be in that way. Because if the three angles are equal, then only the sides got magnified. The angles are still the same, which means they are similar. The angles has to be same. Imagine you are taking a triangle and you are magnifying that triangle. Will the sides change? Yes, the sides got magnified for sure. They became 5 times, 10 times, 2 times. But the angles will be same. How can the angles change? Try this as an experiment. Magnify a triangle. Look at triangle in a book by magnifying glass. Will the angles change? No. The angle will remain same. The sides will get magnified. That's what we are trying to prove here. So when you say that the three angles are equal, I say that the two triangles are congruent, not congruent but similar. When two triangles are similar, the ratio of their sides will be same, which is the extent to which they got magnified. Right? So this is the basic that you're supposed to know, which I'm sure now very much you are clear about it. Okay, because we have been trying very hard to complicate this as we studied this from school. The test for similarity are SAS, AAA, and then so on. I don't know how many tests you study. Then test for congruency is SSS. Then this test, then that test, solved by this test. Why do you need all those things? You just need to know certain simple concepts to solve problems in CAT. Okay, so make sure you know this simple concept, and now we are ready to solve problems on similarity which appeared in the previous year CAT papers.